Alright, today we're going to talk about the defrost timer. This defrost timer comes out of a refrigerator. First we're going to explain to you how it works, what it does, and then we're going to show you how to check it out. In a refrigerator, the evaporator coil operates at about a negative 12 degrees. So any kind of moisture that hits it is going to freeze up. So over a period of runtime, the evaporator will freeze. When that moisture starts to freeze up, it blocks the airflow, so it then hinders the transfer of heat. So your defrost timer, what it does is after a certain amount of runtime, it shuts the compressor off, energizes the heater melts the ice, then it brings the compressor back on, and it can start all over again. So the way it does that is, in your defrost timer you have 4 connections, point 1, 3, 2, and 4. Between 1 and 3 you have your motor. This is your coil for your timer. Once you send power to 1 and 3, the timer starts to spin. It stays connected from 1 to 4, and it could vary. Could be 6 hours, could be 8 hours, could be 10 hours of runtime. After a certain amount of runtime, it then switches from 1 to 4 when 4 goes to your compressor down to number 2. Now it only stays at number 2 for about 20 minutes. That's just long enough to get the ice melted. Once the ice is melted, it flips back up 20 minutes later back to number 4. Let's check that out. So here's the back of the timer. We have terminals 2, 1, 4, and 3. Now what we're going to do first is we're going to check these terminals 1 and 3. Now on a lot of timers, all we're looking for is resistance. So we're just going to set your meter to the ohm setting and look for resistance. It's going to be thousands of ohms, so you'd have to set it up a pretty high scale if you don't have an auto ranging meter. But this motor has a capacitor in series with the windings. So what we're going to have to do now is take our motor. We're actually going to have to set it to microfarads. So I'm going to take it and hook up to terminal number 1. Then hook up to terminal number 3. And we are getting a reading on that. So this coil and capacitor on this is good. So now that we know that the motor section of it is good, now we want to check the switching on it. So now we're going to check from terminal 1 to terminal 4. And since this is a switch, there's no resistance. All we're going to look for here is continuity. So I'm going to take my meter again. I'm going to switch it off of microfarads and switch it over to continuity. I like to always do a quick check, touch the leads together, and it's beeping. So our leads are all good. We got a good connection. I'm going to check from 1. Again, we're checking from 1 to 4 to 4. Let's see here. So from 1 to 4 is good. Now, you can bypass that 10-hour time by taking your motor and manually spinning it. You hear that clicking? That's just bypassing all that time. That's that 10 hours of run time. Now you're going to hear a main click here in a second. Now, that click we just heard, that's turning from 1 to 4. This arrow here just flipped down to terminal 2. So now we're connected from 1 to 2. So we should not have a pad from 1 to 4. We should now have a pad from 1 to 2. So we already hooked up to terminal 1. Let's check terminal 2. And there we go. So now that's the defrost mode. Now, about 80% of this turning was runtime. So we're going to turn it here. Now we're out of the defrost mode. We should be back in the heating mode. So this is a good timer. We had continuity between 1 and 4. We turned it. We had continuity from 1 to 2. We turned it. It dropped out, went back to 4. We checked from terminals 1 to 3, and the call was good. So this is a good timer.